Hello friends, welcome to Humble Mark Academy. In this video guys, we shall be looking at the problem we have on screen guys. It is a problem that is based on Newton's laws of uniformly accelerated motion. So guys, stay tuned, watch the video from start to finish. By that, you're going to understand the entire concept involved. But friends, before you get started, I want us to introduce ourselves guys. I am Umenju Macarius and this is Humble Mark Academy, where I take complex science problems guys, those problems that students find it very difficult to understand. I break it down into tiny pieces, complex concepts that most students and some teachers guys find it very difficult to understand. I break them down into tiny little pieces such that any student across the globe can use his or her understanding of the concept now to score a better mark, or if not guys, the best mark in his or her exams. In exchange friends, all I want you to do is to hit that subscribe button looking at you friends, because I can only help you to pass your exams with good grades once you subscribe to my channel. And friends, please give the video a thumbs up. That goes a long way guys to motivate me to keep creating more great contents for you. Thank you very much guys. Let's dive straight into the video today. Awesome guys, awesome. All right, now friends, the question is saying that given that the surface is smooth and that F is, or that is F has a magnitude of 42 newtons, we should find the acceleration of each block and the tension in each string. And the next part wants us to find also the force exerted on P by the surface. All right, so guys, please, I want you to pause this video and give it a try, then unpause it to check the solution. Come on guys. All right, done. All right, so now guys, I want us to start by examining the entire scenario of the problem as we have. All right, so guys, I have simply reduced the sizes of the blocks because I want us to see exactly what is happening, because we have to apply the physics we know. Okay, if we apply the physics so correctly guys, we are definitely very sure to have this problem solved within a twinkle of an eye. Great. All right guys, let's see if we can cut off each of the strings and analyze what actually is going on with each block. Let's still have some sketch for diagram. Let's have our block P, which has a mass of 4 kilograms. Let's have our block Q, which has a mass of 2 kilograms. Then guys, let's have our block R, which has a mass of 1 kilograms. Great, that's what we have. So now guys, since the entire system is being pulled towards the right, it therefore means that there is some force that is acting on block P towards the right. Okay, great. And guys, since the equation has towards that the surface is smooth, that therefore implies the surface offers no friction force as to the motion of the system. But friends, let's keep in mind that in such a case, the coefficient of friction is 0. Okay, great. So the coefficient of friction of the surface is simply 0. That therefore implies there is going to be no force acting on block P to the left. Okay, there's no force acting on block P to the left caused by the surface. Okay, no force. That therefore implies guys, we only have the force that's 6 to carry block P towards the right, and we can indicate it here with an arrow that this is actually the force that 6 to bring block P to the right. Keep in mind that the force that causes the motion of this system is simply what? F, right? And it has a magnitude of what? 42 newtons. Great. So it is simply F. So now, since this F now pulls the system towards the right, it therefore implies that the motion of our system is to where? Is to the right. That therefore implies the greatest force we can have is towards the right. Right? Good. So guys, we can say that there is some tension in this string, right? And this is how the tension on block P is going to look like. This is the direction. We can call that tension T1. Now guys, in accordance to Newton's third law of motion, which simply tells us that what guys, forces always exist in pairs, right? So if we can have a force that seeks to take block P1 to the right, that therefore implies, in accordance to Newton's third law of motion, we should also have a force that tries to opposes T1, and that force has to be what guys? In a counter direction compared to where? T1, right? And since Isaac Newton told us that these two forces are equal in magnitude but opposite in direction, that therefore implies this force, whose direction is towards block P, also needs to have a magnitude of T1. Great. So now, guys, this is how we can see the entire problem that is happening on block P. Then, guys, looking at block Q, again, in accordance to Newton's third law of motion, we must also have a force that tries to prevent block Q from moving towards the left, right? Because T1 seeks to bring block Q towards the left. In accordance to Newton's third law of motion, we should also have a force that seeks to oppose T1 that is acting on block Q. That therefore implies we are going to have the force in this direction, okay? Since these two forces should be equal in magnitude and opposite in direction. That therefore implies, guys, we are going to call that force, we are going to call that force T2, okay? Great, T2. So now, guys, T2 is simply the force, it is simply the tension on the string, okay? It is simply the tension on the string that connects Q to R. Great, so this is T2. And guys, there is also a force that does what, guys? That opposes T2, okay? And that force has to act from where? From block R towards block Q. So we can have the magnitude of the force be like this. And in accordance to Newton's third law of motion, guys, these two forces have to what? Equal in magnitude and opposite in direction. So this as well has to be T2. Wait. Alright, then here obviously we have this our force F. We have F. Great. Alright. So guys, please, if there's something you didn't understand, guys, don't forget to leave your worries in the comment section down below, guys. Let me know what you think about this question, okay? Let me know the level of difficulty you had, because my assumption is that you paused the video and you gave it a try, and then you unpause you now to check the solution. So guys, let me know it in the comment section down below. If there's something you didn't understand, guys, don't feel free to let me know, guys. And if you understood the entire concept, guys, based on my explanation, guys, let me know in the comment section down below, okay? That's going to motivate me a lot. All right. So now, guys, now that we have everything set up, guys, it's time now to apply Newton's second law now to solve the problem, which we are going to apply the Newton's second law of uniformly accelerated motion, which we are going to use the version that talks about a body of constant mass, okay? Because we know that Newton's second law of motion has two versions. We have the version where the mass is not constant, and that which the mass is constant. So guys, I have a video on that. Please check it. Please just go to my channel and check it, guys, okay? Go to my channel and check it. I'll put a link to that video in the description for your convenience. So make sure you check that video, guys. It's going to give you a clear understanding on Newton's second law of motion as an overview, okay? It's going to actually teach you what you might have mistaught, okay? Great. So we are going to be using the Newton's second law of motion, which simply tells us that, guys, for a body of constant mass, in this case, guys, the sum of all the forces, that is sigma F, that is the sum of all the forces, guys, has to amount to the mass of that body times its acceleration. Great. Keep in mind that F and A are vector quantities. That's why you see me having arrows. Great. All right. So guys, if you look at block P, if we examine block P so well, guys, we'll see that we have what? We have just one horizontal force acting on block P, right? Which is simply what? T1. That therefore implies, guys, our T1 in this case has to be equal to what? The mass of block P times its acceleration. The mass is what, guys? 4. Acceleration is A. Great. So we can simply call this our equation 1. Friends, there's something I want to draw your attention at. Keep in mind that the equation wanted us to find the acceleration of each of the blocks, right? But keep in mind that since with the application of this force, the entire system moves at once at the same acceleration. What I'm trying to say is that the entire system will have the same acceleration, so we expect each of these blocks to have the same acceleration. So we'll just denote it as A. Great. So now, guys, if we look at block Q, we could see that well, there are two forces acting on block Q, right? We have the tension T2 and we have what? T1. That therefore implies, guys, since the motion is towards the right, it therefore means that T2 has to be what? Bigger than T1, right? It therefore implies we are going to have T2 minus T1, which is giving us what? The mass of block Q is what? 2 times A, which is A, which is 2A. We can call this our equation 2. Guys, if you now look at block R now, we will see that there are two forces acting on block R, right? We have the applied force, which is actually F. Then we have the tension T2. That therefore implies we are going to have our F minus T2, which is going to give us what? The mass of R, which is simply 1 kilogram, A times A. So we just have A. We can call this our equation 3. So now guys, what then is left now is just for us to solve for our unknowns. Okay, that is all what we need to do now. The physics is over. Okay, the physics, guys, is over. All we have to do now is to solve for our unknowns. We are going to apply more physics in the last part. Okay, in the last part. All right. So guys, if we simply add up the two equations, the beauty of doing so is that T1 cancels T1, T2 cancels T2. We are just going to left what? F and A, but we know F, right? So we can get A. So if you sum up our F, our equation 1 plus 2 plus 3, guys, that is simply going to give us F to be the same like what, guys? 4 plus 2 is 6, 6 plus 1 is 7, so we have 7A. But don't forget that our F is simply what, guys? 42 newtons, right? So if we solve that so well, guys, we are going to have 42 equal to what? 7A. That therefore implies, guys, if we solve for A, we are going to have our A to be 6 meters per second. All right. That's what we have, guys. That's what we have. So friends, please don't forget to like the video, guys. Give it a thumbs up. Subscribe to this channel, guys, if you want more great content from me, guys, because I post content in this my channel, guys, every day of the week. Every day, guys. So keep checking out the video. Keep checking out the channel, guys. You're going to see more interesting, great content for you in all the sciences, guys. All right. So guys, now since we have the value of the acceleration, guys, we can go ahead now to solve for all the tension. So if we examine our equation 1, guys, we'll see that T1 is equal to what? 4A, right? But what is our A, guys? Our A is 6 meters per second squared. So guys, please correct this error, okay? Here has to be 6 meters per second squared, not per second. Not per second, please. Per second squared. All right. So from equation 1, guys, we can say that our T1 is equal to what? 4 times A, which is 6. That therefore implies our T1 becomes what, guys? 24 newtons. Since the tension is a force, it has a unit of newtons. Then, guys, from equation 2, right, we can see that our T, we have T2 minus T1. What is our T2, guys? It's our unknown, right? What is T1? T1 is what? Is 24. So we are going to have our T2 minus 24 equal to 2 times acceleration, which is 6. So we are going to have 2 times 6, which gives us 12. That therefore implies, guys, our T2, when we carry 24 to the right hand side, we are going to have T2 to be 36 newtons. Wait, that's the force, that's the tension, T2. Now, guys, since we have the tensions, we have all the tensions acting on the string and the acceleration, right? We can therefore go ahead now to solve the next part, which simply wants us to find the force exerted on P by the surface. All right. So, guys, let's look at a free body diagram for block P. Okay. Keep in mind that these are not the only forces acting on these our blocks, but we were more interested in the horizontal motion of the block since the blocks are accelerating in the horizontal direction. There is no acceleration of either of these blocks in the vertical direction, right? So that's why we inserted only the forces towards the horizontal direction. Now, guys, let's look at the free body diagram for block P in the upward direction. Let's look at this block P. Great. So now, guys, we know that block P is a mass, right? That therefore implies it must have a weight, and the weight must be pointing downward. And according to Newton's law, right, the weight has to have what magnitude, guys? The mass times the acceleration. The acceleration in this case, guys, is simply the value of g. That's the gravitational field strength of the earth. So the mass of our P is what, guys? 4, right? So it has to be 4g. So the weight has to be 4g. Great. And guys, the weight of this of block P is balanced by what? Is balanced by the normal reaction force, which is what we need to find, okay? Because it is simply the force exerted on block P by the surface. So we can call that R. Okay, let's call that R as normal reaction force. All right. So guys, there's something I want you to understand. This is where most students will get this is where most students are going to apply the wrong physics. Guys, keep in mind that the normal reaction force and the weight do not constitute Newton's third law pairs. Okay, they do not constitute. Now, if you're being asked to list pair of forces that constitute Newton's third law pairs do not mention the normal reaction force and the weight. There are so many reasons you can account for it, okay? There are so many reasons you can account for it. One condition that we must impose for Newton's third law to be obeyed is that what, guys? The two forces must act on the same bodies, right? But in this case, we see that what the normal reaction force is doing what, guys? Is acting is simply acting on the particle, right? It's simply acting on block P, whereas the weight is simply acting where, guys, vertically downward, right? Good, guys. That therefore implies that we can simply say that these two forces now, guys, cannot constitute Newton's third law pairs. But in this case, guys, we can simply say that the normal reaction force, guys, is simply balanced by the width of block P, okay? Not that it constitutes Newton's third law pair. Great. So, guys, in this case now, our arrow simply becomes what? 4 times G. So, guys, let's just take our G for simplicity. Let's take G to be 10 meters per second squared. In this case, we're going to have our arrow to be 40 newtons squared. Since arrow is a force, guys, it also has a unit of newtons. So, guys, thank you so much for watching the video, guys. Thank you so much. I hope you found it useful, guys. If you found it useful, like I said, guys, give it a thumbs up. That goes a long way to motivate me to keep creating more great content for you guys. As always, guys, feel free to subscribe to the channel and turn on your bell icon to get notified, because I upload videos, guys, every day, every night, guys. Have a blessed day.